You can always see the board. Guess what? I could too, but sometimes we don't get to do it. Guess what? I can see the board, but I get to see this board. Okay, so today we're going to start solving the system of equations. So there's three different ways we're going to learn how to solve it. We're going to learn substitution, which is today. We're going to learn elimination using addition, which is coming up later. And elimination using multiplication, which is coming up next week some point. So, today we're going to learn substitution. Alright? Kellen, when I say substitution, what does that mean? Hey, you do. What does it mean to be a substitute? Take place of, right? When I have a substitute teacher, they come take the place of me, right? Pretty much at that point we're equivalent. They become the teacher in this room, right? Anybody ever done any baking and they're like, you can substitute applesauce for eggs? Did you guys know that? That's called a substitute. You substitute something in for something else. So today we're going to learn how to solve these equations using substitution. Everyone ready? Okay, so we're going to start off with journals out. Everything I write down gets written down inside your journal today. Understand? Title it. Substitution. So we're going to start off as basic can get. We're going to look at this. So remember, in this whole chapter, we're playing in the world of two. Corbin, come sit next to Janae so you can see. Corbin, sitting back there going like this. Okay, so substitution replaces something. Now remember, we're in the world of two equations from now on, right? So this is our two equations, y equals x minus 5 and y equals 6. We do have two different equations there. In order to solve these, we have to solve for x and we have to solve for y. So how many answers are we going to have? 2. Just like when we found where the two lines cross, it had two answers, technically, right? It had an x and a y. It just was an ordered pair, so it's one answer, but it technically had two. This one right here, it's extremely easy. If the equations are both y equals, you're going to set the two equations equal to each other. So because they're both y equals, we can go 6 equals x minus 5. So all we're doing basically is we're grabbing this 6 and we're substituting it in for this y. Now who could tell me why can I do that? Because they're both y equals. So all we're doing is we're taking what y equals and we're putting it in for y in the other equation. So, Braxton, can you solve that for me?
5 to 6.
Oh, you're kidding. So x equals 11. So there's one answer. How would I get y? Matthew? Yeah, we do.
11 into the original.
Good. So we can then plug 11 back into the x, which is right there, and we solve it. Or as Braxton said, technically we already had x. Already had y. They already told us. But I like being able to see. So after you get one answer, you're going to plug it back into your other equation to get the other one. Okay? So, all right. We're going to go through one right now, and I'm going to write, not yet, we'll write down steps here in a little bit. Okay, so if we have this, y equals x plus 17, and y equals 8x minus 11. So they're both y equals, right? So what we're going to do is we're going to take what this y equals, and we're going to plug it in for y in the above equation. So it's going to look like this now. 8x minus 11 equals x plus 17. At this step, you should only have one variable. We shouldn't have x's and y's still. Do we only have one variable in this? Just x's, right? Good. So now we can solve this. So, Dre, how do I solve this?
You add the x's together.
Okay, how do I do that though?
You just add x from zero.
Good, so we're going to get the x's on the same side. So that's going to give us 7x minus 11 equals 17. Then what, Dre?
Add 11.
Add 11.
Then divide by 7.
So x equals 4, right? So there's one answer. 1x minus 8x minus 1x is 7x. So now we have 4. Okay, we got one of the answers. Now we need to go back and get y. So what are we going to do with this 4? Doesn't matter which equation I plug it in for. No. This is really cool. It doesn't matter when you go to plug it back in which equation you plug it back in for. I would pick the one that's the easiest. Which one of those equations is going to be easier? The top one. But I'm just going to show you. So if you plug 4 in for that one, you get y equals 21. Right? If you're a serial killer and you decided to plug it into the bottom one, you still get the same answer. Does everyone see that? So it doesn't matter which equation you plug it in for, you get to the exact same solution. So the moral of this one, if they're both y equals at the very beginning, you set them equal to each other. Okay, I'm going to let you guys try one on your own here. So if we have y equals x plus 57 and y equals x plus 15, go for it. 8x plus 15. Is that what I said? Hi, Dre. Hi, Ray. Now that looks like a super puffy coat. You're not done yet, Axton. Get going. Corbin, you done? God, I need to join American Idol. I'm sick of this. I'm win. Gotta win. Got ya. Because winning really is the only thing. Get out of my way, I'm coming in. If you want to, step in front of me. Entity, you got this? How sure are you? Okay, what did you do? Okay, so 8x plus 15 equals x plus 57. Did everyone agree with her on that? They're both y equals, so you just set them equal to each other, right? Okay, Entity, what did you do next? Okay, we got to get the x's on the same side, so we're going to get 7x plus 15 equals 57. Griffin, what did you do next? Oh, don't. Yeah, there we go. So 7x equals 42. Then, Riffin, what does it equal? Yeah, so we got what x equals. Okay. Orban, what'd you do?
I plugged it in on the top one.
Nice. Did anyone plug it into the bottom one? Don't do it. One of them, all you have to do is just plug it in like that. And you get y equals 63, right? But if there is the weirdo in here, like there always is, every class, I plugged it into the bottom one. Well, good for you. No one cares. Right? Then you can still get the exact same answer. But okay. All right. Any questions on if they're both y equals? Any questions on that? Braxton done? Any questions? Braxton, I mean, sorry, pronounced your name wrong, my bad. Okay, onward and upward.
You made it finally.
Of course I did. Okay,
There's a piece literally.
prove it. Okay, write down this one with me. Okay, we got quite a bit harder here now. Now, instead of them both being y equals, now we have a problem where one of the equations has a variable set equal to an equation and the other one's a mess. Does everyone see that? So the first thing you're going to identify is one of the equations, does one of the equations have a variable by itself? Which equation has a variable by itself? The bottom one. And then you need to identify, okay, one of the equations is one of the variables is by itself. Which variable is it? X. So what we're going to do is, because x equals this, we're going to grab this and we're going to substitute it into the other equation for x. Because x equals this, we're going to grab it and we're going to substitute it into the top equation for x. So what this is going to look like is 5 times 3y minus 13 minus 4y equals negative 32. So it's still a substitution problem. Does everyone see that? Even though it's just x, because it's x equals, you're going to plug it in for x. If this happened to be y equals, you would plug it in for y. Okay? All right, look. Now look at this same exact thing. Is there only one variable present here? Yeah, there's just y's, right? No more x's. So now we can solve this equation for y. So, Matthew, how do I do this? I like it. I think I already called one Matthew. What's 13 times 5? 65.
Wait, 13 times 5?
Nope. Medium sized. Okay. Abin, what would you do next, just out of curiosity? Well, this isn't inside of your book. This is something new. I'm just curious what you would do.
Add 65, or, yeah.
Okay, we could do that. I wouldn't do that. I would leave this over here. What I would do before I add 65 is I would go 15y minus 4y to get 11y. Okay, now Avin. Now I would add 65. So we're going to have 11y equals 33 or y equals 3. What do you think I do with that 3 now? Which equation would you plug it into? The top or the bottom? Bottom. Don't plug it into the top. X is, we had to solve for x, so all we're going to do is we're going to go x equals, we have y equals 3, so we have 3 times 3, we plug in that 3 back in, minus 13, or y equals negative 4 is your solution. I said x, see? It's been x the whole time. What are you talking about? Huh, Fred? Raxton? Raxton. I forgot you were Raxton. Alright. Any questions so far? Okay, we're gonna do one more of these, and then I'm gonna let you try one on your own. And if we do good enough, we may go to homework. But first, we got to do one more, and then I'll let you try one on your own. Then we do the merry dance, and then we sing hallelujah. Hallelujah. Okay, here we go. Y equals 2x minus 5. 5x plus 4y equals 6. Does one of the variables have a variable alone? Does one of the equations have a variable alone? Yes. Which variable is it? So we're going to grab this 2x minus 5 and we're going to plug it into y in the other equation. So it's going to look like this. 5x plus 4 times 2x minus 5 equals 6. Nope, look, because y equals this, you're going to plug it into y. Up here, if you remember, x equaled it, so we plugged it into x. It's whatever is equal to it. Alright, so now we're to there. Ellen, what did you do here? What did you do next? Starts with the D, ends with distribute. Good. So we're going to distribute. Wow. Okay. Who can raise their hand and tell me what to do next? Braxton?
5 and 5x and 8x.
Good. And then we go through and we can just solve the rest of this equation. So 13x equals 26, or x equals 2. So we got one of the answers, right? What do we got to do to get the other one?
Plug it in.
Anybody ever heard? You guys know what Glade is? Glade? I'll find that thing for you. It's kind of like that. It's like it was something you used to plug in to make your house smell better.
Yeah.
And they used to do this thing. They used to have this commercial. It's like plug it in, plug it in. I'm gonna play it for you here in a minute. But anyways, if x equals 2, now because x equals it, we're gonna plug it back in for x. So we're gonna get y equals 2 times 2 minus 5, or y equals -1. Okay, we're going to try one of these on your own. You guys ready? X equals 3y minus 5. Negative 3x plus 5y equals 11. Plug it in, plug it in. I'm going to pull it up, and somebody's going to say a bad word, and I'm going to make myself look like an idiot. It's usually what happens, you know? Is it Glade?
Yeah.
1998 is when they came out with this commercial. That was before you guys were born.
I still have one.
So you guys ready?
Hey Rita, isn't it about time to change that Glade plugins refill?
Refill your Glade plugins every 45 days to keep your home Glade fresh.
Plug it in, plug it in.
Here. Plug it in, plug it. Ready again? Here we go.
Hey lady, isn't it about time to change that Glade plugins refill?
Refill your Glade plugins every 45 days to keep your home Glade fresh.
Plug it in, plug it in.
There's all kinds of these.
Hey Mom, isn't it about time to change that Glade plugins refill?
Refill your Glade plugins every 45 days.
They did all kinds of these commercials. The first one's a dog, the next one's a fish. That's a baby. This one's a cat. Nope, it's a pirate.
Someone refill that Glade plugin for lasting freshness. Don't forget to refill.
Keep
your
doing
Glade
this problem.
Plug it in, plug it in. For lasting freshness.
Told you. You guys all thought I was crazy. No, the dog's the one that's crazy telling me to plug it in. Plug it in, plug it in. Your turn, Daxton. Alright. Sorry, distraction. I'll give you an extra minute. You guys got distracted by the talking baby too. I did too. Not bad. Pause for a second. Everyone look up here. Hopefully everyone took what x equals and plugged it into x. So I'm going to give you this part. Take what x equals, plug it into x. Keep going. The first thing you should be solving for is y. Corbin, you done? Corbin cheated. Corbin is the man who's been running from the man that goes by the name of the Sandman. He dries his eyes like an eagle in the sky, like a hurricane that's man. Corbin is a man who's been running from the man that goes by the name of the Sandman. Corbin likes his eyes like an eagle in the sky, like a hurricane. Work this every day, dude.
No, but still.
All right. Okay, first thing we're going to do is we're going to distribute, right? So we're going to get negative 9 plus 15 plus 5y equals 11.
That's where I went wrong.
That's a bad place to go wrong at the very beginning.
I think it's.
And then we're going to combine together the y's. Now this is where I figured some people would go wrong right here. If you went 9y plus 5y and got 14y, you're wrong. Because it's a negative 9 plus 5, which is negative 4, plus 15 equals 11. Subtract 15. Negative 4y equals negative 4. Y equals... Who in here got y right? Raise your hand. Not bad, not bad, not great. Okay. It's because you went negative 9 minus 5. Remember, look up here. This is what a lot of people got hung up when we did this before. These are on the same side of the equation, so you just combine them. You don't subtract 5y to this. If they're on the same side, all you have to do is combine them. So now we have what y equals, so we're going to plug it in. And we're going to get x equals negative 2. Who got them both right? 4 of us? 5 of us? 6 of us? Okay. Hey, look up here again just so you guys know. Look. It's very important you understand. If the y's are on the same side of the equal sign, all you're going to do is combine them. You're not subtracting 5y over to this or adding 9y to this. It's not that way. They're not across the equal sign from each other, so all you're going to do is just combine them. That's it. Your assignment's there. 6-2, 6 problems. All of them are like the ones we did today.
What I did wrong was.
Hey, Braxton.
I subtracted the 15 instead of adding it. You
You guys seem to have it.